Right, so this thing here is a oil level float sensor from a Toyota Coaster. Right, so let's try and get behind the camera a bit better so I can see what I'm doing. Actually, let's just change this a bit more. Here we go, that's better. Right, so it's a float sensor from a 1996 Toyota Coaster. This is the what was it? 1HD engine, I think it is. HDTZ. Oh god, I can't remember. Anyway, it's got the turbo diesel on it, 4.2 litre. Right, so this is this float sensor out of it. Now I've been having problems with erratic level indicators appearing on the dashboard. So sometimes the dashboard light would come up and say that the lower oil level, well, the oil level is low, and it's because of this sensor here. So actually, what I did is I unplugged this connector here, and I made up a little jumper which is in my pocket. Oh, if I can find it. It is. So I made up this little jumper, right? Just got some little spade connectors and trimmed them down a bit so they fit inside to simulate these two pins. And I plugged this into the wire loom connector instead. And the problem went away. No more issues with oil level warnings. So it was not a wiring fault or broken wire somewhere. It's definitely the sensor playing up. So the oil level is definitely fine. Also, so if you get an oil level check, make sure the level is actually okay, because that's the most obvious thing. It could be low, but I know in my case it definitely wasn't low. It's been playing up ever since I got the vehicle a couple of years ago, and it's been getting worse. So I wanted to deal with it if I could. So I'm doing an oil change right now, and so I pulled the sensor out. This is not normally this clean. It's normally covered in engine oil. It's usually black. So I've given it a clean up already, but I wanted to show what the thing actually looks like. So it's got this float here, just sits like that, okay, and it just floats around. It's a very loose fit, and it's actually got a bushing here which is actually rubberized. That black there is actually like a rubber membrane there. See it just there, flex it slightly, and I don't know, maybe it's binding on that slightly or something, or I don't know, but you know, it's grabbing on it slightly. So maybe that's part of the problem, is that membrane there is deteriorated a little bit and it's making it grab. But otherwise it's quite free flowing. It moves quite easy, you know, it wobbles around. It's all, you know, fine. Okay. Now what these basically have is got two connections. One goes onto the body, got a metal framework here, and the other comes through this wire here. They're soldered onto these metal plates. They go through. This one here is riveted, and interestingly, that's interesting. That doesn't quite make sense. Oh, okay, that's fine. So it's soldered onto there, goes to the metal plate. It's got these terminals here which go down, and there's a rivet goes through which is insulated from the body. Alright, so it's not actually connected to the body. And then there's this connection here which is soldered. So somewhere there is a reed switch. Alright, there's a reed switch in here somewhere. Alright, this is obviously just a magnet. It could be that these fail because the magnets get weak. That could be all it is, the magnet's getting a bit weak. That could be all that's wrong. Yeah, somewhere in here's a reed switch. I'm thinking it might be inside this post, because it's soldered top, soldered bottom. The bottom goes to the frame, the top goes to that wire there. It's also soldered to there too. I mean, that could be, there's two reed switches, I don't know, but that goes to there, which seems to be insulated. So I'm not too sure. It could even be in that one. Alright. I will have to experiment and have a look. But yeah, I thought I'd just show how they look and, you know, how they're constructed. Now the thing is, this is giving a low level sometimes. So it's also consideration, maybe, because this is metal pressed, maybe over time the stresses are coming back out of it and it's trying to straighten itself back up. where the metal relaxes because of the heating and cooling effect. It gradually returns back to its original shape. So it could even be that this is slightly bent upwards. Although, so I've actually flexed it down to a fraction now. Right, so it's now going down a fraction. See, it's supposed to be like that. You can see it's going downwards slightly now. So I'm hoping that might help it. It gives it, another, couple of millimeters in the bottom there. 2 or 3 millimeters in depth there. So that may help, just changing the angle a little bit. But yeah, I'm going to have a little play around and see if I can figure out where the actual reed switches are, and go from there and see what the resistance is and that kind of thing. So I'll come back in a second. Okay, so I thought I'd just play around with the actual switching. So I've hooked up my meter there to ohms. Now originally I was getting 30 ohms resistance, and I've been playing around with it, and I found that this little nut here on the back wasn't that tight. I just gave it a little bit of a turn and the resistance dropped off. And the same for this one here. I gave that a little bit of a turn as well. It's both a little bit loose. So I've given both a turn, and now it's sitting at about 0.4 of an ohm, which is like the resistance of the leads anyway, I think. So look. Yeah, it's pretty much no resistance, right? It's the resistance of the leads. I haven't nailed that out. Moving the float around, however, isn't causing it to change, right? Which I haven't been able to get it to actually trigger yet. So maybe it's got something to do with when it's inside the housing or something. It affects it differently. I don't know, maybe there's something else which is affecting it. But if I get this magnet here and I put it near to this point, it opens up, okay, and closes again. So I just want to play around with this and just see if there's any kind of errors in the actual readings. I mean, this doesn't really seem to be magnetic, this float here. So that's quite interesting in itself, there's no magnetism there. I get magnetism here. I can feel magnetism just there, actually. That's repelling, which is quite interesting. Anyway, so yeah, I'm just going to play around with this to see if I can get it to fault. But so it's repelling the magnet there. So there must be a magnet on the end there. Interestingly, that's repelling. I can feel it pushing away. Right, but not on the float part. And the float is where I thought the magnet would be in, but it's not doing that. So I'm quite interested in how this is working. I'm trying to determine. I can feel it repelling there as well. So that piece there must be magnetic, obviously. Where the sensor is, I don't know. It's in there somewhere. It's got electrical connections through here and through here. It's a little bit of a mystery, really. But yeah, so I'm just playing around with this and just going to see if I can get this thing to actually give me a fault. But I think since I tighten these up, that might be what was wrong. So, because there's 30 ohms through there, even at the best condition, there's 30 ohms. So when that switch is closed, so it could be all it was that those are loose, and that's what's wrong with it. I mean, this is just working fine right now, So I think I'll put it back in as it is, refit that, and see what happens. But it is interesting that this isn't actually triggering any switching, but you'll think it would do. Anyway, that's enough of that for now.